Um, Thanks everyone for coming to this presentation by the Sabancı University and Cyprus Sabancı Museum in the partnership with the Creativity and Technology platform Digilog. My name is Osman Serhat Karaman. I'm the manager at Digital SSM Archive and Research Space. I'm here serving as a representative for the research project named Technological Arts Preservation. I want to introduce our illustrious speakers. Today we are treated with the presence of Fino-Radin, who is the founder of the New York-based labs, Small Data Industries, which aims to support and strengthen society by conserving the permanence and integrity of the world's artistic record. He led conservation initiatives at Rhizome, where he worked as a digital conservator and later as an assistant media conservator at the Museum of Modern Art in New York. At the same time, he directed the design and development of the digital warehouse of the same institution. With that, I will just let him take it away. Again, thanks everyone for coming. We are very excited. Dear Ben, please.
Sure, thank you so much for that lovely introduction, Osman. So let me just share my screen here. All right, so you should all be able to see my slide now. Great, so let me just hide my floating meeting controls. Wonderful. So thank you again so much for the invitation to speak to you all today. This is my first time traveling to Istanbul virtually. So before I begin today's talk, I would like to acknowledge that I am speaking to you from New Hampshire in the United States of America. This area where I am at is known as Ndakina, the unceded homeland of the Winnipesaukee people of the Pennacook tribe and the Wabanaki Confederacy. My ancestors came to this area in the early 20th century as white Europeans, and despite the narrative of self-madeness and bootstraps that my immigrant family likes to embrace, it's of course indisputable that we stood on the shoulders of centuries of violence and hate against Native peoples, as well as centuries of violence and slavery perpetrated against people who were brought here from another continent. And acknowledging this context is all the more important on today, a very important day in the United States of America known as Juneteenth, which is this year the 148th anniversary of when the last slaves were freed in America from their bonds. And this was a whole 2 years after slavery was deemed unconstitutional in the United States of America. So as a professional dedicated to cultural heritage, I am only at the start of what for me will be a lifelong journey to dismantle systems of colonialism and white supremacy within myself, my country, my community, and the spaces that I create as a small business owner. So as you heard, my name is Fino-Radin, and I'm the founder of Small Data Industries. And we are a mission-driven lab based in New York. And that mission is to safeguard the permanence and integrity of the world's artistic record. And we do this by supporting and empowering people. So we fulfill this mission through a variety of consulting and services in conservation, collections management, coaching and mentorship, helping to design and deploy preservation systems and technology, and also building and deploying products. And we do this work with everyone from artists to art collectors, institutions, estates, and nonprofits. And we've been very fortunate and lucky to work with world-class institutions all over the world. So today we're here to talk about virtualization. And before we dive in, I just want to give a quick overview. I don't want to assume that everyone who's attending today's talk is familiar with virtualization. So let's do a quick kind of overview. So let's say you have this whole mess of computers and each one is a little bit different and configured in very specific ways. So it seems a little impractical to have all these machines sitting around taking up space, right? So why don't we do something about that? So we're going to draw a little box over here, and let's call this our virtual environment. And so what we're going to do is take a little snapshot of each of our machines and then place those within this virtual environment. And we'll do this repeatedly until we only have one computer left. And that one computer that we have left we'll call our host machine. And the computers that we have turned into virtual machines are called guest machines. So our little laptop here is the host of our virtual environment, and our virtual machines are guests within that environment. And there are two very common tools that are used for creating and managing virtual environments like this. One is VirtualBox, and that's free and open source software. And another very common one is called VMware. But running these virtual environments on your own computer isn't the only way of going about doing this. So in an enterprise setting, such as a museum, a museum, it would be much more common to run your virtual machine data center, let's say. And so with this background established, I would like to now kind of dive into the meat of what we're going to be talking about today. So a lot of what I'm going to be talking about today will centralize around the artwork of Dublin and Vienna-based artist John Gerard. Gerard's installations, such as Solar Reserve, which you see here installed at Lincoln Center in New York City, often consist of a very graphically intensive piece of software. And so essentially, John Gerard uses video game engines. His works are infinite in duration and they are generative. And Gerard has used two different video game engines over the course of his career. So whenever you see one of John Gerard's installations, such as Western Flag, seen here installed at Desert X in Palm Springs, I believe a couple of years ago, whenever you see these installations, behind the scenes there is a PC with a very powerful graphics card and very powerful graphics capabilities, because everything that you see is being rendered in real time. It's not video. So for what we're going to be talking about today, I want to focus on a very particular artwork of John Gerard's, and that is Sow Farm from 2009. So I'm going to be focusing on this work in particular because this work was the focal point of a Tate Modern case study in 2015, a few years ago now, into the viability of the potential use of virtualization for graphically intensive works, such as John Gerard's work. I really highly recommend checking out the link here, and I can post this in the chat afterwards. And that Vimeo link is a video where the leaders of the case study, Patricia Falcao and Annette Decker, present their full findings at Tech Focus 3, which was held at the Guggenheim in 2015. So I don't want to be too reductive of their findings here, but three key findings in their research were that, first, the virtualization tools available at the time didn't pass through the host machine's graphics processing unit, or GPU. So VMware actually was the only virtualization platform that could even run the work because it has a built-in virtual GPU. And lastly, although it did run, the results in VMware with the virtual GPU, or vGPU, were not sufficient. The artwork ran very slow, it was very laggy, and there was a kind of anti-aliasing, which is essentially a way that edges are smoothed over in a video game engine, that was very critical to how the work looked and felt, and this just simply didn't work at all. So, in the intervening 5 years since then, there has been, of course, exponential growth in industries that are heavily reliant on the processing power of GPUs. So this is everything from, gaming, of course, these are video game engines, but also virtual reality, blockchain, any kind of blockchain technology relies on GPUs, machine learning, and artificial intelligence. Of course, these industries have grown exponentially in the last few years. And this has really created a market demand for GPU-powered virtualization platforms. So Paperspace is one of those platforms, and we'll be looking a little bit at Paperspace today and how we leveraged it to run artwork. So Paperspace is used for everything from, again, machine learning to cryptocurrency to gaming. And so cloud-based gaming rigs are actually gaining popularity, as these give gamers the ability to have incredibly powerful gaming rigs, but with no actual hardware of their own to maintain or take up space. So our architecture now looks like this. Our host machine lives in Paperspace's server farm, which has a whole slew of graphics processing units at our disposal. And we access this virtual machine through our web browser. And so if you've ever tried to set up a virtual machine, you can attest to what a pain it can be. But fortunately, these cloud-based platforms really do make this process a lot easier. So I wanted to just illustrate to you how simple this process is. So the first step in Paperspace is to choose which data center region you want to create your virtual machine within. So there are data centers in Amsterdam. That's unfortunately right now their only European node. And then in the USA, there's one on the East Coast in New Jersey and one on the West Coast. So I'm on the East Coast of the USA, so let's pick that data center. And then Paperspace has various pre-built templates. So what I'm going to do here is choose the Parsec template. And if you're into video games, you may have heard of Parsec. It's one of the various cloud or remote gaming platforms. So here I have the option of what kind of graphics processing unit I want to use. So I'm going to choose the cheapest one for right now, which is an NVIDIA Quadro M4000. So it's really important to note, this is an actual physical dedicated GPU, which is a very different and novel thing for virtualization to have access to. So I'll click create, and really only 15 seconds later, I'm running Windows full screen in my web browser. And one of the interesting things about Paperspace to note is that no matter the size of your browser window, it almost always looks kind of like pixel perfect because it actually scales the resolution of the virtual screen to exactly the dimensions of your browser. So of course, we now have to install the artwork, which in the case of this particular John Gerard piece, South Farm, is done with a one-click launcher that the studio provides. So we'll run the artwork, and there you have it. South Farm running flawlessly in my web browser. And thankfully, Gerard includes a diagnostic heads-up display in South Farm. So that's this text that you see overlaid. That's actually not part of what a viewer would typically see for the artwork, but we can press a button when we're running the work and get certain diagnostics about how well it's running. And one of these diagnostics is frame rate. So which, as you can see here, is it's a little pixelated, but it's 60 frames per second, which is a phenomenal frame rate for a video game engine. So to drive home the point, this is the computer actually that I was running this test on. So this is an 8-year-old MacBook Air on actually only moderately decent Wi-Fi, you know, because everyone's working remotely right now. So this was from home. And I would note that although the data center is all the way in New Jersey near New York City, I ran these tests from the countryside in rural New Hampshire. So the connectivity seems to perform quite well. And I would love to have shared a live kind of video preview with you here over Zoom, but video can be pretty unpredictable and laggy on Zoom. So instead, and I'll put this in the chat later too, this is a link to a Vimeo video that's a screen recording of this running in the browser, so you can see kind of start to finish how smoothly it runs. And we can potentially also provide these slides as a PDF to the attendees afterwards. So there is one pretty big issue, however, with Paperspace for our purposes, which is showing artwork. And that is this pesky little dot in the corner. So this is the Paperspace menu button, and this overlays the entire view of our virtual machine, and it can't be hidden, it can't be removed. They could easily add that feature, but for now you can't do that. If there's any web nerds in the audience, you could very easily create a Chrome extension that removes that for you because it's just an element in the DOM. But that's a little bit much. So let's explore maybe some other options. So as I mentioned, we're using a Parsec template. So Parsec essentially is, if you run this pre-installed Parsec software on your virtual machine, and then you download a Parsec client on your computer, either Mac or Windows, or it might actually only be for Mac, you now can access your virtual machine through the Parsec software instead of just Paperspace's web browser interface. So this has a few major advantages. So let's take a look at that. So here we see our Parsec client running in a window in Mac OS. So you can see, again, it's still our same virtual machine, but we're kind of in a different interface. We're not accessing it through our web browser. So this is a zoomed in view of the Parsec client's equivalent of that Paperspace button. But as you can see, they have the ability to hide the button. So much better. Another great thing about the Parsec client is that the resolution of the virtual machine is persistent no matter how you scale the window you're viewing it within, or if you go full screen. So this is important. I mentioned previously that Paperspace's interface will scale your virtual machine to be a native resolution to whatever the dimensions of your browser are. And this isn't always what you want to happen. So for instance, if you are running an artwork through Paperspace, say in your museum, in your gallery, and it's being projected full screen, if you were to access that from the back end on Paperspace, it could potentially resize it, and that's not good, obviously. So it's actually ideal that Parsec doesn't do this scaling, so it won't impact any kind of resolution issues when you log in from the back end. So we've been doing some work now to take this kind of approach a step further. What I've been showing to you so far has been basically the ability to remotely access a machine for the artwork to run on. And when you access that machine, you have full control and access to the operating system. Now, that might not always be what you want to do. Say you're loaning an artwork to another institution. It would be nice if there was a way to give them access without necessarily having full access to the original software or even source code or just even changing settings that don't need to be changed. So what we've been doing is basically connecting our Paperspace VM, which is again in the cloud, to Twitch or YouTube or Vimeo or any other streaming service. So this gives you a 100% cloud-based workflow where our little administrator here can directly access and control and administrate the virtual machine and the artwork running on that virtual machine. But then the general public, be it, again, a borrowing institution who's streaming the work in their gallery, or somebody accessing things online publicly and openly, they only experience that as essentially a live video stream. So we've been pushing this approach really to its outer limits through a collaboration with Bitform's gallery. So if you go to this URL later today or right now, bitforms.art/stream, you'll find a live streaming generative artwork by Daniel Kanagar. So all summer long, we're collaborating with Bitform's gallery and showing a series of about 8 different generative works of art streaming live full screen at this URL. So again, this artwork is actually, it's not streaming video. When you see it, you're seeing a real-time performance of software. And this is all running in the cloud. So circling back to the prior work in this space, all of Annette Decker and Patricia Falcao's findings about virtualization still apply. So there's one major exception, of course, and that is that virtualization can now accurately reproduce the significant properties of the John Gerard work that we were talking about. So I would add a few pros and cons to this approach of using cloud-based virtualization, however. So on the pros column, this approach really is, we've found more than good enough for exhibition. We've sent, through our collaboration with Bitforums, we've had artists looking at it constantly. And through our collaboration with John Gerard, we sent the studio a screen capture recording of the streaming artwork, and everyone has felt pretty good about it. In the case of the Bitforums collaboration, it's not perfect. It really does depend mostly on your internet connection. So if you are using that approach to stream an artwork within a museum with very good broadband, it's probably fine. But if you're streaming it out to the general public, some people might see it like slightly compressed. But it also depends on what the imagery within the artwork looks like, because compression can look different depending on the content. So this is a very useful tool for assessing software-based artworks. You can run an artwork that has demanding hardware requirements without having to buy any dedicated hardware. Long-term, of course, that is a good recommendation to acquire that hardware. But initially, sometimes you need to just get going. We do think that this is a way to securely loan software-based artworks without having to share the actual software. And again, there's no need for expensive and complex computer hardware. So any computer that can run Chrome, that can run a web browser, or that can play a video on YouTube and has a good internet connection is really more than enough. And I've actually personally been able to stream these works on my cell phone pretty easily. And lastly is that, these streams are non-interactive. So it's a way of sharing software-based artworks easily without necessarily giving full control of the software or of the machine. So the downsides, this is not a preservation strategy. These cloud-based platforms may come and go, and it's really not a long-term method of preservation. This really should be seen as a tool for assessment or a tool for exhibition and public access. It's not free, of course. This does cost money, and I'll get into what the pricing on Paperspace in particular is. One of the major downsides is, at least with Paperspace, you can't export a disk image, which would be essentially a offline snapshot of how you have configured the software. Not the end of the world, but again, this drives home that this is not necessarily a preservation strategy. One of the downsides currently with Paperspace is you can't move machines between regions. So that's a problem, because if, let's say you are a museum based in Istanbul and you create your Paperspace machines in the Amsterdam data center, and let's say you're loaning an artwork to an institution in the United States, so you want to move that virtual machine to one of the data centers in the US. There's unfortunately right now no way to do that. And then, lastly is really just the fact that outside of Central Europe and the United States of America, Paperspace doesn't have any other data centers. So performance will vary greatly depending on where in the world you are. So circling back to the cost, it initially, when you look at the pricing of cloud-based platforms, can seem very, very expensive. But once you actually kind of extrapolate these costs and really see what the full cost is, it's actually not that bad when you compare it to, so let's say with this John Gerard piece, you would have to buy a specific dedicated computer, you would have to ship that computer and ensure that. So for the machine that we were using for Sow Farm, the John Gerard piece, if you were to run that for 3 months, 24/7 all day, that would come out to around just over $1,000 US, which isn't, again, terrible within the scope of pricing for loaning artworks between institutions, especially considering the utility that you get out of this. So that concludes my talk today. I thank you all for listening, and we have plenty of time for discussion, so I'm more than happy to field any questions that you all may have. And if you don't get a chance to have your question answered today, my email and Small Data's social media and phone number is right there on the slide. So thank you so much. So somebody asks, what about Unreal pixel streaming for Unreal, obviously? Also Docker with NVIDIA Toolkit instead of VirtualBox, also AWS instead of Paperspace. Personally, the only one of those I could really speak to is I do know that John Gerard's studio had done some experimentations with using Paperspace, or with using AWS for running something in the cloud. And I'm sorry, no, I take this back. It was not John Gerard. This was actually Daniel Kanagar's studio. And they were successful in that. So really, when it comes to cloud-based platforms that give you access to a dedicated GPU, it's more about what features they give you. And personally, I find Paperspace easier to use than AWS, far easier to use. And yeah, it's just it's a lot more user-friendly. Which, can be very important when, in the context of a museum, the person setting this up might not always be an IT person. Sometimes you might have like an art conservator or a registrar who's actually doing the setup. So the question was, do most studios use Unreal or Unity? What about open frameworks? VVVV, I've never heard of that one, or Touch Designer. Yeah, so mostly these days, I've seen most artists using Unity. It's really only gained in popularity. I've only seen in our lab a few works come through that use Unreal Engine. Yeah, I think Unity's just gotten better and better. I mean, I personally have no preference, of course, but that's just what I've been seeing. We really surprisingly haven't dealt with many works that use open frameworks. It is actually a tool that we have used ourselves in our own work as conservators. But I've never, we've never had artwork come through the lab that uses open frameworks. Plenty of Touch Designer. We've worked on a few Rafael Lozano Hemmer pieces, and they've used Touch Designer. Okay, so we have some more questions. Do you think paperspace.com will provide anything specific for new media art? That's a great question. I don't know, probably, probably not. I think, any kind of intersection of art and technology where, art folks, or be they artists or museums, are using a technology that is already out there in the world. Unfortunately, we have very little sway because we're such a small, small slice of the market, really. But I mean, the good thing is that it's hugely popular with gamers, and I mean, really, it's when you're looking at a video game engine-based artwork and a video game, there's very little differences technologically. So the interests of gamers are very much advances the needs and requirements of artists in that case. And of course, the standards of gamers are very, very high. And there's actually, in the field of preservation, there has always kind of been a very interesting push and pull, or not push and pull, but really, I guess what I'm getting at is, in the preservation field, we've benefited from other communities. So for instance, for the preservation of analog video, for a long time, the standard file format that you would use for digitizing analog video would be a 10-bit uncompressed QuickTime MOV file. But more and more people are using FFV1 encoded Matryoshka files, which it sounds like a mouthful, but basically it's a openly documented container and codec that is a very, very efficient preservation, compression that's good for preservation. And that actually came out of the piracy world, people who are like pirating and selling illegal movies and TV shows. But now that format is being used in archives. So Yeah, unfortunately, it's not very common to see, industry that's building new tools really, start from the use cases of art, but it's more common that we benefit from the byproducts of other communities. Cool. And somebody's saying VVVV is pretty cool. You should know it. I will look into that. Very excited to learn more.
I have a question.
Sure.
My question is about a bit different about this authenticity. My question refers to Morgan Stricott's article titled Digital Art Preservation, Practical Answers to Ethical Issues. If we ultimately reinterpret the artwork in a new technological context, how do we know if we have kept its authenticity? In other words, authenticity and long-term access and irreconcilable conflicts. What do you think about?
Yeah, that's a great question. So I think I would first encourage that we maybe move away from the word authenticity as necessarily the best word for talking about time-based media art, because change is inevitable with time-based media. We can't completely stop change. So artworks will change. It's more about what is an acceptable degree of change. So a notion of like fixed authenticity doesn't necessarily really translate very well to time-based media. So it's more, for me, it's less about authenticity and it's more about having a fidelity to the artist's vision, so defining like what are the work defining properties. Another word that's used in digital preservation is like significant properties. So understanding like what are the things that really, really cannot change and what are the things that can change. So ultimately, in order to assess the success of any kind of option, be it cloud-based virtualization or something else, we have to understand that first and foremost. We have to understand the artist's intentions. We have to understand the significant properties or the work-defining properties in order to be able to assess that. But really, at the end of the day, once you do know those things, it's, seeing the frame rate is fine, but it's more about looking, it's more about seeing, it's more about knowing the work. A big part of working in conservation, whether you're working on a painting or a sculpture or you're working on software, is really having a connoisseurship of the artwork that you're working on.
Okay, thank you so much. Do you have any question to Ben? I think that's all. Okay. Thank you, Ben, accepting our invitation and contributing to our research project. I hope to see you soon again.
Thank you so much for the invitation. I deeply appreciate it. And thank you so much for everyone for attending. And thank you for being understanding with the technical difficulties.
Thank you so much again. Have a nice weekend.
All right, thanks. You too. Thanks, everyone.
Thank you.